So let's now see an interesting application of Simpson rule, and you can apply even trapezoidal rule as well, but most of the time Simpson 1/3 rule is applied. So let's solve a problem. A solid of revolution is formed by rotating about the x-axis the area between the x-axis lines x is equal to 0 and x equal to 1, and a curve through the points with the following. So this is all the question with the following coordinates. Okay, so coordinates are given. Okay, let me just tabulate it and then we'll explain what it means. So this is x, this is y. So x0 I have 1, y is 1, x is 0.25, y is 0.9896, x is 0.5, y is 0.9589, it's 0.75, this is 0.9089, this is 1, this is 0.8415. Okay, so now we need to estimate the volume of the solid formed using Simpson rule. Formed using Simpson's rule. Okay, so this is what we have to estimate. So now first of all, just basic idea. So if you have something like this, a curve something like this, and you want to rotate this about x-axis, you'll get a solid of revolution object. So how do we, so if you take a small strip here, okay, small strip here, so this is my y, okay, and this is x, and this has become dx. So this area, this disk, when I rotate the area of the disk, when I rotate this strip, the area of disk will be pi y square into dx, right? Pi y square, y is the radius, so pi y square will be the area. So this will be basically the area of the disk will be pi y square, but the volume of the disk will be that area of the cross section, which is pi y square into the width of the disk. This is area of cross section of the disk, and this is the thickness of the disk. Okay, so the volume of the solid will be basically solid generated total volume will be basically the integral of this pi y square into dx, and he said between the limits 0 to 1. So this integral we need to evaluate. So the problem boils down to evaluating this integral. So this is basically a function pi y square. Now y is given, so we can easily evaluate pi y square, right? Pi y square is a constant. I mean, we can evaluate y square. So let's calculate this. 0 to 1 pi y square dx, I can write pi. Okay, and so by Simpson rule this will become, so this will become pi into now h by 3, Simpson rule. Now the end terms you have to just add. So end terms you have, this was y0, y1, y2, y3, y4, and you have square terms, so pi 0 by 540. End terms you are adding, then 4 times the even terms, 4 times the odd terms, which is y1 square, y3 square, and 2 times the even term. The even term is only y2. So y square, because the function requires square, the function is pi y square dx. Okay, So now it's just lays down to substitution. Okay, so h, this is pi, h is basically 0.25 equal interval by 3, and then you have to just substitute. Y1 is 1, so 1 square will be 1. Y4 is 0.8415 square plus 4 times 0.9896 square plus 0.9089 square plus 2 times 0.9589 square. Okay, so this you have to just substitute, and pi is 3.1416 by 3. So this, when you substitute, so this when you evaluate, it comes out to be, just you have to substitute 1.7, sorry, this is 1.7081 plus 7.2216 plus 1.839. So this on simplification gives rise to 2.8192. So this is just so you can instead of areas, you can just find out the volume of solid generated also, because it's all boils down to evaluating the integral. So look at the integral, and then whether it's area or volume, it doesn't matter, just it evaluates a definite integral. Okay, so the approximated value of the volume of solid is 2.892 2.8192 by this method. So this is the thing, you can easily evaluate basically basic integration. So this is one of the application of Simpson's one-third rule. So similarly, there are a lot of problems, I mean, and it boils down to applying this simple method. Okay, so the volume of the solid approximately is 2.8192 units cube. Okay, so I think we have seen good number of problems in the numerical integration. Now let's see how numerical methods are applied to differential equations.